Assalamu alaikum. Today we will do exercise 10.4. So the question number 1 of exercise 10.4 is, given a cylindrical tank, in which situation will you find the surface area and in which situation volume? So we are given a cylindrical tank. Last time, if you remember, I told you about the volume in the surface area. I gave you a brief idea about what volume is and what surface area is. I'll again tell you that. For example, this is a cylindrical tank. For example, the amount of matter it can hold, be it liquid, solid, it can be anything, it can be water, it can be oil, it can be milk. So the amount of that matter it can hold will give the volume of this container, and the area of its outer surface, including the bottom and the top, this will give the total surface area of the cylinder. And if we were to find only the lateral surface area, then it would be the surface area of the cylindrical part, that's the lateral part, not the top and the bottom, without this top and bottom. So there are three things. One is the volume, which is the amount of matter it can hold. Second is the total surface area, which is the area of the top plus bottom plus area of the cylindrical part. And then third is the lateral surface area, which is without top and bottom area. So the question number 1 says, you are given three statements. You will have to say whether it can be represented with the volume or the surface area. The first one is how much it can hold. How much it can hold. See clearly, A part is how much it can hold. I already told you that the amount of matter it can hold gives the volume. So A part, its volume. For B part, what's the B part? Number of cement bags required to plaster it. See, if we have to plaster it or paint it, we will paint its outer surface and the bottom surface and the top surface. We won't fill the tank with paint. We won't do that. We will only paint its surface. So for that, we will have to find the surface area of the cylinder. So the B part's answer is surface area. The third part is to find the number of smaller tanks that can be filled with water from it. See, the question is saying if this is a tank and it has water, it's filled with water, then there are other small tanks, small tanks, 1, 2. If we have to find the number of these tanks to be filled, see, we will decide how many tanks will be filled only when we will know the amount of water in it. And what is the amount of water? It's again the volume. So for C part, it's again volume. Moving to question number 2. So the question number 2 is, diameter of a cylinder A is 7 cm and the height is 14 cm. Diameter of cylinder B is 14 cm and height is 7 cm. Without doing any calculations, can you suggest whose volume is greater? Verify it by finding the volume of both the cylinders. Check whether the cylinder with greater volume also has the greater surface area. See, we are given two cylinders, A and B. One is A like this, and another is B. It's like this. It's A and it's B. For A, we are given the diameter, it's equal to 7 cm and the height is equal to 14 cm. For cylinder B, the diameter is 14 cm and the height is only 7 cm. We have to find the volumes of both these cylinders and decide which one is greater. After finding the volume of these two, we also have to find the surface areas of these two and see if the cylinder with greater volume has also the greater surface area. Let's find the volume of A first. Volume of cylinder A. See, we know that the volume of a cylinder is equal to pi r square h, where pi is equal to 22 by 7, r is the radius of the cylinder, h is the height of the cylinder. So for cylinder A, pi is 22 by 7 into r square. What's the radius? Radius is 7 centimeter, so 7 square into h. What is the height? It's 14. So this comes out to be equal to, sorry, this 7 is the diameter, so radius will be, see, if diameter is 7, what will be the radius? Half of 7. So we will write 7 by 2 whole square. What does this mean? 7 by 2 into 7 by 2. 7 by 2 is the radius of this cylinder. So this comes out to be 539 centimeter cube. For volume we write centimeter cube or meter cube, and for area we write centimeter square or meter square. Now again for cylinder B, volume of cylinder B is equal to pi r square h. Pi is 22 by 7. What is r? What is the radius of cylinder B? 14 by 2, right? Because 14 is the diameter, so 14 by 2 is the radius. We will square it into height. What is the height of cylinder B? It's 7. So the volume comes out to be 1078 centimeter cube. So clearly this is the volume of cylinder A, this is the volume of cylinder B. Which is more? Obviously the volume of cylinder B. So we will write, which implies that volume of cylinder B is greater. Now the question also says that we have to find the surface areas of both these cylinders, okay, and then decide which one is greater. So first of all we will find for A. Now comma, total surface area of cylinder B is equal to, see, the total surface area is equal to the lateral surface area plus the area of top and bottom. We know the lateral surface area of a cylinder is given by 2 pi r h, okay. So we have to add the area of the top and bottom. What is the area of top? Pi r square. And what is the area of the bottom? Pi r square again. So it's 2 pi r h plus pi r square plus pi r square means 2 pi r square. We can take 2 pi r common. Here it remains h, here it remains 1 r. So this is the formula for finding the total surface area of a cylinder. So for cylinder A, okay, we have written first for B. So for B it's 2 into 22 by 7. What is the radius? 14 by 2. In the bracket we will write what is the height? 7 plus what is the radius again? 14 by 2. So the total surface area of cylinder B comes out to be 616 centimeters square after calculations, okay. Similarly, total surface area of cylinder A is equal to 2 pi r into h plus r. That's equal to 2 into, what's pi? 22 by 7. What's r? Radius of cylinder A is 7 by 2, because 7 is the diameter, so 7 by 2 is the radius, into h is 14 plus 7 by 2. After calculations this comes out to be 385 centimeters square. So what did you see? The surface area of cylinder B is greater than surface area of A. So clearly the a cylinder which had the greater volume had the greater total surface area as well. So this solves your question number 2 as well. Moving on to question number 3. Okay, so the question number 3 is, find the height of a cuboid whose base is 180 centimeter square and volume is 900 centimeter square. We are given a cuboid. You know what a cuboid is, right? This is a cuboid, for instance. What are we given? We are given the height of the cuboid. Okay, no, we have to find the height. Let it be h. We have to find this h. We don't know h. Okay, we are given the base area of this base. For example, this is the base. This is the base of this cuboid. Its area AB, area of the base, is 180 centimeter square, and its volume is equal to 900 centimeter cube. We have to find the height. Now we know volume of a cuboid is equal to length into breadth into height. In our case, see, this is the length L, okay, this is the breadth B, and that is the height h. Length into breadth into height. See, area of this base, area of the base, what is it? It's length into breadth, because it's a rectangle, right? It's length into breadth. So length into breadth, it's given as 180 centimeter square, is it? See, volume of a cuboid is given 900, so we will write 900 instead of this volume, is equal to length into breadth into height. Instead of length into breadth, we will write 180 centimeter, 180 into height, which implies that height is equal to 900 divided by 180, that is equal to 5 centimeter. This is the required answer. Moving on to question number 4. Okay, so the question number 4 is, a cuboid is of dimension 60 centimeter into 54 centimeter into 30 centimeter. How many small cubes with sides 6 centimeter can be placed in the given cuboid? See, we are given a big cuboid. This is a cuboid, for instance. Its dimensions are given. What is the length? It's 60 centimeter. Length is 60 centimeter. What is the breadth? Breadth is 54 centimeter. And the height is 30 centimeter. We are told, if we fit this whole cuboid, if we fit it with small cubes, fill it, whole of it, because cuboid has space inside it. For example, last time I gave you the example of a matchbox. If we fill a matchbox with small cubes, for example sugar cubes, for instance, we need to tell how many cubes are required to fill this whole cuboid. And dimension of one cube is given. We are given, what are we given? The side of the cube is 6 centimeter. If one side is 6, then another side will also be 6, and the third side will also be 6. All the sides will be 6 centimeter. So see, volume of the cuboid we will find first. You know the volume of the cuboid is length into breadth into height. So here length is 60, breadth is 54, and the height is 30. So this comes out to be, after calculations, equal to 97200 centimeter cube. After that, we will find the volume of one cube, one small cube, that is required to see. We have to fill this cuboid with number of small cubes, but we have to find the volume of one cube first. You know the volume of the cube is length cube. That's equal to, here length of the cube, what is it? 6 centimeter. So 6 cube, that's equal to 216 centimeter cube. Therefore, number of cubes required to fill the cuboid is equal to volume of cuboid divided by volume of 1 cube, that is equal to 97200 divided by 216. This comes out to be 450 cubes. So this is your answer.